All right, so today we're going to talk about deductive reasoning. So yesterday we kind of talked about inductive reasoning when we talked about conditional statements and whether something may or may not be true. Today we're going to talk about deductive reasoning, which is a process of reasoning that's we're going to logically process of reasoning. Don't break nothing back there, weirdo. Logically and drawing conclusions Yes, sir. Can you move where? Oh, because you're blind? Yes. From given facts and statements. That was a mouthful. Okay, so deductive reasoning is the process of reasoning logically and drawing conclusions from given facts and statements. The first law we're going to talk about is the law of detachment. And it's a conditional statement. If my hypothesis is true, then the conclusion is true. If my hypothesis is true, then my conclusion is true. So if we are in geometry class, then today is Tuesday. Is our hypothesis true? Are we in geometry class? Then our conclusion must be true because it's Tuesday. Now the symbolic map. What our hypothesis always got what letter? P. Conclusion got the. Okay, so if P and Q, and I got a new little symbol for you, little Hunger Game status. P over dot 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 Q. Does anybody know what the three dots mean? To be continued, that'd be an ellipses. So these dots are kind of stacked. Anybody recognize them from a video game? Okay, the little dot is the symbol for therefore. Therefore. So essentially what it's saying is, if P then Q, P is true, therefore Q is true. P is true, therefore Q is true. I'm pretty sure that was a video game symbol, wasn't it? Anybody recognize it? No? Maybe we'll find it in the comments. All right, so let's look at some of our examples. We're going to use the law of detachment and give a valid conclusion. So what must be true to be able to use the law of detachment? The hypothesis must be true, therefore our conclusion is true. So it says, if Mark saves $30, then he can buy a new video game. Oh, Peter. So we've got our hypothesis and our conclusion. Okay, so Mark saves $30 is our hypothesis. Can buy a new video game is our conclusion. So our statement is, Mark saved $30. So from that statement, what can we conclude? Okay, so Mark saved 30. What happens according to our conditional statement? If he saves 30, then he can buy a video game. So Mark saved $30. What can he do? He can buy a video game. So our conditional statement, it has to have, if Mark wants a video game, he better save $30. Well, guess what? Mark mowed some lawns, did some chores around the house, and bought a 6-year-old game because that's how much they cost. So he can't buy a new one with that. So Mark saved $30. What can we conclude? Mark bought a video game. Mark can go ahead and buy that video game. What if Mark saved $29? Could he have bought a video game? Not yet. What's he got to do to be able to buy one? Got to get to 30. Let's look at our next one. If a quadrilateral is a rhombus, then it is also a parallelogram. Unit 4, baby. Woo! So we've got our hypothesis. A quadrilateral is a rhombus. Our conclusion, it is also a parallelogram. They tell me quadrilateral ABCD is indeed a rhombus. So based off the law of detachment, what can we conclude? That it is a parallelogram. Yep. So we can conclude because quadrilateral ABCD is a rhombus, we can conclude that it is a parallelogram. ABCD. There's a lot of L's in there. Given, if you are 18 years old, then you can register to vote. Our hypothesis, you are 18 years old. Our conclusion, you can register to vote. Olivia is not 18 years old. Can we draw a conclusion from that? Can we say that? All we can say is, does this statement match this conditional statement? If you are 18 years old, you can register to vote. Olivia is not 18. She could. So can we make a valid conclusion from this statement? Because like Cole said, what if she's 27? What if she's 14? Do we know enough information to draw a conclusion? No. So we're going to go no valid conclusion. Oh, come on now. Oh, rascal. So no valid conclusion can be drawn. Based on that conditional statement, they need to tell us that Olivia is 18, or we can't assume anything. The next one says, if the sum of the measures of two angles is 90, that's our hypothesis, our conclusion is they are complementary. They tell me the measure of J is 58 and the measure of K is 32. So let's do a little quick math. 58 plus 32. 8 plus 2 is 0. Carry the 1. 1 plus 5 is 6. Plus 3 is 9. Well, old school. So what can we conclude about it K and J? So if they add up to 90, they're what? No, they're complementary. Does that match? So what conclusion can we draw about J and K? Angle J and angle K are complementary angles. Okay, one more. If you plan to attend prom, is our hypothesis, then you must purchase a ticket. Sarah purchases a prom ticket. What conclusion can we draw? What is it? Sarah's going to prom? Oh, you're just... What was our hypothesis? Does Sarah plan to go to prom? Why? Does that mean she plans to go? So, what must be true first? The hypothesis must be true first. By Sarah purchasing a prom ticket, do we know anything about the hypothesis? She might be. Can we go on might be? In order to draw a valid conclusion, the hypothesis must be true. Sarah bought a ticket. Does she plan on going? Maybe. But can we draw a valid conclusion based on that? No. No valid conclusion possible. What's that? What statement would have made this better? Nope. Sarah plans to go to prom. So what conclusion could we have drawn? She's going to buy a ticket. So it's all about that hypothesis. All right, so that's our law of detachment. The law of syllogism becomes a little more complicated. I know, I'm sorry. So the law of syllogism, we're just suspended animation out there. We can draw a conclusion from two conditional statements. It's almost like a chain. One thing's going to happen, then another, followed by another set of events that goes along with the first one. The conclusion of the first statement becomes the hypothesis of the second. The conclusion of our first statement becomes the hypothesis of our second. So you guys are going to see when we get to our examples, the conclusion is going to need to match the hypothesis. If not, we can't draw the same conclusion. So the symbolic map, our conditional statement, P then Q, leads to Q then R. Oh yeah. Therefore, ... we can assume or we can conclude P can go straight to R without the Q. So if we look at our symbolic map, hypothesis, conclusion, Conclusion's going to go right to a new conclusion. So instead of our original one, we're just going to go original hypothesis to final conclusion. It'll be a little easier when you look at it with numbers or with words. Okay. Use the law of syllogism to give a valid conclusion. If not possible, write a valid conclusion. So if it's Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So what's our original hypothesis? What do you think? Without the if, right? It is Saturday. What's our original conclusion? Jake has a baseball tournament. Our next conditional statement. What's our new hypothesis? Jake has a baseball tournament. And then what's the conclusion we can draw from that? He will need to pack his lunch. So, does the conclusion of my first conditional and the hypothesis of my second one, do they match? Yes. So we're going to write a new conditional statement leaving out the middle part. So what's that? What do y'all think? What do y'all think? New conditional statement leaving out the middle part. If it is Saturday, then what? Jake will need to do what? He needs to pack his lunch. Do you have to do this for every class? Yes. Yes. What's that? Because it's like if I do that, then everybody's just writing while I'm talking, and it's not as effective. Like if I'm like writing, that gives them time to write, and then we can talk. Does that make sense a little bit? Yeah. It's fine. It is my job after all. I am working smarter. Don't worry about that. All right. Our next one. What's our original hypothesis? A number divisible by 12. It is divisible by 6. The next one's got to be a number is divisible by 6. And then what's our final conclusion? It is divisible by 3. You're good. Do our initial conclusion and our second hypothesis match? Are they saying the same thing? Yes. So we can write a new conditional statement, essentially pulling out the middle part, because that's going to be true. So what's my new conditional statement? If a number, what? Is divisible by 12, then what? It is divisible by 3. If a number is divisible by 12, then it is divisible by 3. Look at number 3. A quadrilateral is if a quadrilateral is a square, then it's a rectangle. If a quadrilateral is a rectangle, then it has 4 right angles. What's our initial hypothesis? A quad is a square. Then It is a rectangle. What's my next hypothesis? A quad is a rectangle. What's my final conclusion? It has 4 right angles. So what's my conclusion? What can I draw? If a quad is a square, then it has 4 right angles. Perfect. Not too bad, right? Just a lot of words in math. All right, let's look at our next one. If it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear shorts. So we've got it is sunny this weekend. You will go boating. But uh-oh, what happened? They went back to the original hypothesis. And then our new conclusion is you will wear shorts. So using the law of syllogism, can we conclude anything about these two statements? No, because we can't say, well, you're going boating, so you're going to wear shorts. So there is no valid conclusion here. No valid conclusion. My original conclusion and my new hypothesis did not match. If you shop at the Target, you will use your Target Red Card. If you don't use your Target Red Card, you will not get 5% off. So what's our original hypothesis? You shop at the Target. What's our original conclusion? You will use your Target Red Card. What's my new hypothesis? You do not use your Target Red Card. You will not get 5% off. They're pretty close. Why is it purple? Why is this green and that purple? They're inverses of one another. They've been negated. So is this conclusion the same as this hypothesis? No. So can I draw a conclusion based off of my two statements? No valid conclusion capable. So they try to be tricky. Can't write in highlighter, dummy. No valid conclusion. That's why it's purple. Ethan said, where did purple come from, coach? All right, last example. If it snows, then school will be canceled. What if it doesn't snow here? If school is canceled, then the students will need a makeup day of school. Man, I'm glad we don't do that. We might have to this year, though, if it snows, because we're behind on days anyway. Extended summer. So what's our original hypothesis? It snows. Our original conclusion? School will be canceled. Next hypothesis? School is canceled. Then finally we conclude? Students will need to make up a day of school. Can we draw a conclusion from this? What's our new conditional statement? If it snows, then what? Students will need to make up a day of school. That sounds awesome, doesn't it? All right. So that's our deductive reasoning, law of detachment, law of syllogism. You guys have my math lab. You have plenty of time, I think, to finish it and not have any homework tonight. You need something to do in study hall? Oh, Peter. Sorry, Hannah, I broke it.